welcome to the next segment. Okay, so just to rehash what we've got so far. One, you know that light is a wave, where light is a shorter wavelength than red light, right? Two, you've learned that sound is also a wave, actually, and it has this thing called the Doppler effect. And the Doppler effect the sound coming toward you will sound a higher pitch, and moving away from you will sound a lower pitch. Okay? Next, I'm going to change gears here for a second, and I want to talk about some science that was done. Actually, now we're getting to American science. I was an American scientist, and we're talking back in the 30s. The discovery of galaxies. Okay, I remember from way back when Galileo was the first scientist who ever used a telescope to look at the stars and stuff like that. Well, he saw things like the moons of Jupiter and the phases of Venus. Uh, People started using telescopes and they started building better and better and better telescopes, okay? Bigger and more powerful ones. And so what I want to get into here, now, by the way, this is a picture of the edge viewed from Earth of the Milky Way galaxy. We're in the Milky Way galaxy, so we can only see it edge on, right? Nobody's ever seen it from the outside because you have to be 500 million miles away. Okay, so write this down. Galaxies. Oh, if you didn't write that one down, write down galaxies. That's what we're talking about now. We're talking about the big structure of the universe. We got the sun, we got the planets. Now we're getting way further away. Galaxies. Okay, here's something that was a mind-blowing discovery. The sun is one star in a vast cloud of stars we call the Milky Way. Now, on a warm summer night, when you go outside, away from the lights, like if you go out camping or something like that, you can see the Milky Way as this sort of streaky area in the sky. And that's, by the way, everybody could see it, but now that we have street lights and lighting and stuff like that, that all reflects off the sky. And so when you're in the city, it's really hard to see the Milky Way. It's just the stars aren't very brilliant and bright because you have too much what's called light pollution. But when you get out away from the city, you can see the Milky Way. And I highly recommend if you go camping or go on a trip and you're out in the middle of the desert or somewhere where you're away from city lights, take a look up and see that Milky Way. It's awesome. Okay. Now, one of the scientists that studied galaxies early on was a guy named Edwin Hubble. Edwin Hubble, truth is, he hasn't gotten nearly as much credit in history of science as he deserves. People that really know history of science give him plenty of credit, but he should be much more well known. Einstein, Newton, Galileo, everybody knows him. Edwin Hubble. Now, you've heard the name Hubble because of the Hubble Space Telescope. He did not use or invent the Hubble Space Telescope. It was named after him. The Hubble Space Telescope is a telescope that's in outer space. It's in orbit out of Earth's atmosphere, so it can see really clearly. The greatest telescope ever made was named after him. Okay, so I'm glad his name became real well known because of that. But Edwin Hubble, 1889 to 1953. So he passed away 5 years before I was born, right? If you picture where is that in history? It's after the Civil War when he was born, and he lived through, we had the era of the 20th century with the Depression and World War I and World War II. Now, most of his work was done in the 30s, which would have been before World War II. Okay. Now, his also Mount Wilson Observatory. This is the telescope he worked with. This was in California. And it's like a big, large telescope, way better than the telescope Galileo got to use. What this here is to keep rain off of it, right? And they'll slide this door open and let me center this a little better. Okay, so they slide the door open and it keeps it dry in there and it can look out and they can turn the dome to aim it wherever they want. And you can see the size of it here. This is like a rail. So a person would be like, this big on this picture. Okay, so this is a pretty darn big telescope. And he studied galaxies. And he was one of the guys that first classified galaxies. It would be nice to spend more time with galactic classifications and stuff. EO, E3, E7, ESO. Okay, what these stand for here, the S stands for spiral galaxies, right? The E stands for elliptical galaxy, so they're doing it by shape. An ellipse is kind of an oval. Spiral. And then we got the SB, which is kind of a broken, more open spiral than the tight spirals, just the S type. So he developed this classification system for galaxies, studying different galaxies. People were wondering, what are these things? They actually came out when they first discovered it with the name for them as island universes, which is kind of a cool name. But galaxies. Now, if you want to think about the universe, we can look out and we can see things beyond the stars. All the things we see are visible stars, right? But there are others you can see with telescopes. Some are visible, big enough to be seen with the naked eye, but they're too dim, right? A telescope, you can open the aperture and expose it for a long time, so really dim light can detect things like the Andromeda Galaxy. You can see it with your naked eyes if your eyes were sensitive enough, right? But anyway, the point is here, they realized that galaxies, they didn't know what they were at first, but he helped figure this out. These aren't stars, they're galaxies of stars, right? So the Andromeda is the closest spiral galaxy to us, right? There are some that are the Clouds of Magellan, they're called. They're a little more diffuse, but there are some galaxies that are kind of closer to us. But the Andromeda is the closest main galaxy. It's in the Andromeda constellation. That's where the name comes from. And they estimate it has, okay, how many zeros is this? You don't have to write it down. You can if you like. But what do we got? There's the hundreds, thousands, millions, billions. About 400 billion stars are in the Andromeda Galaxy. Now, each of these little dots that you see, those are all individual stars in our own galaxy. But you can look past outside of our galaxy and see the Andromeda. And the distance, it's about, okay, again, counting zeros, these are the hundreds, thousands, millions, about 250 million light years away. That means the light from the Andromeda Galaxy took about 250 million years to get to us. And light is the fastest thing in the universe. That's 186,000 miles per second. That is, a long ways away. So those are the galaxies, right? That's what we're talking about. And there's a whole bunch of galaxies. But here's the deal. Since it takes light a time to get here, I want you to write this down. When you look into deep space, you are also looking back in time. You're seeing light that came out 250 million years ago from the closest one, right? These get further and further and further away. When you start looking and they start appearing smaller and stuff. Okay, if you haven't written that down yet, soak that idea. You're looking back in time when you're looking out at, if you're looking at the sun, you're seeing light that came from it about 6 or 7 minutes ago, right? But if you're looking at the galaxies, it was like 250 million years ago or more. Now, we do live in a galaxy of our own. We call it the Milky Way. And the sun would be essentially here. This is what nobody's been outside to see what it really looks like. But this is what they can map out and figure out, oh, okay, this is probably what it looks like. And the center is in the direction of the constellation Sagittarius. Now, we can't see the center because it's blocked by dust, interstellar dust. So the light gets blocked, so we don't have this. If we didn't have the dust, it'd be a big, bright thing in the sky, but there's not. But the sun is about there. Here's one. I love this picture. This is the Sombrero Galaxy, is what it's called. You can see that the edge on the arm, you can see that there's a lot of dust in there that will actually block the light. And that's why we can't see the center of our own galaxy. Here's an interesting one here. This is two galaxies that have collided together, where they've basically, in slow motion, they're merging into a single galaxy.